Hello dear students, welcome back to my YouTube channel and very good evening to all of you. Am I audible and visible to all of you? Am I audible and visible to all of you? One second, I need to check it out if I'm audible and visible. Yes, so I am audible as I can hear it by my own self. Okay, so as you know that only one topic is left now, that is friction. So in this particular class, I will try to just complete the friction topic today, and from tomorrow we will be starting circular motion. Okay, today I will try my best to complete the whole topic of friction, and we will do some good numericals also, some basic things of friction also, and the important topic discussions. And after that, tomorrow we will start in the circular motion, more probably. Okay, so for today the main topic will be friction. So we will be starting friction from basics to end. Okay, if you want me to ask anything, you're most welcome. I will be taking 2 to 3 minutes to hear it from your end if you have anything, right? So I will be waiting for your turn. Until then, I will just do some basic work from my own end. So yeah, 1 second. Okay, so that means we need to start now. Okay, I hope my is visible to you now. Okay, let's check it out now. Okay, so today's topic is friction. Today's topic is friction. So we will start friction. Okay, what is friction? Starting question will be, what is friction? Okay, so I will be giving you a very normal and very concise definition of friction. Basically, when two bodies are in contact, when two bodies are in contact, there is a contact force. There will be a contact force, right? And we are having multiple components of this contact force, just like normal. Normal is also my contact force. In the same way, we are having a friction. We are having a friction. So I can write here, friction is the parallel to surface component of contact force. Okay, it always opposes relative motion between surfaces. So friction is that component of normal force, that component of contact force which is parallel to the surface, and the working of friction is it always tries to stop or tries to oppose the relative motion between the surfaces. Easy definition. Okay, look now, if we are having a surface, if we are having a surface, no, this is my surface. This is my surface. We are having a surface, okay? Look now. This is my surface. Done? So this surface is the object is having mass m. Object is having mass m. So we are having two components here. One component is, look, if it is going in this way, there will be two components, one component and one more component. Okay, look here. If this is my external force, this will be my normal force. This is my contact force. This will be my frictional force. So what is frictional force? It is that component of your this contact force which is parallel to your surface. Which is parallel to your surface. Done? Easy. And there is a question now, why there is friction? What is the main cause? What is the root cause of friction? So the main cause of friction is, look now, if we zoom here, right? So you will find two layers of objects. One layer is this one. One layer is this one. And one layer is the smaller one. This one, right? So we are having two surfaces. So I am just showing the two surfaces on the molecular level. Now, as you can see here, when you are pushing this one in this way, that means you are disturbing its configuration. Okay. Now, what will be here? Look, this will go rightward. So the lower one will opposes it. So it will apply a force in this way. In the same way, this will oppose it. So you can see, right? There is a frictional force. And it opposes its motion. Why? Because it restores its original configuration. This opposition is known as friction. This opposition is known as friction. So what friction is all about? It is the opposition of your external force, or it is the opposition to your slideness, to your motion. Done? Okay, this is modern view. Now you can see here, if we talk about the types of friction, so we are having two types. One friction is dry friction, and one friction is, I can say, wet friction or fluid friction. Okay, fluid friction. In dry friction, we are having static friction. Second part, we are having kinetic friction. Here, in fluid, we are having only one type, that is viscosity. That we will be studying in fluid mechanics. So now in this particular lecture, we are going to focus on these two friction types, that is static friction and kinetic friction. Good evening, beta. Sakib beta, good evening. Okay, we are having two types of friction. One is static and one is kinetic friction. Okay, now what is static friction and what is kinetic friction? So let us start with the static one. Static friction. Okay, so before relative motion, starts, there is a one friction. There is a one friction, and that particular friction is known as static friction. What is the meaning of it? Let us suppose you are having a car, no? Or I can say you are having a car, right? This is my car. Okay. Now the car broke down, and you are trying to push it. Okay, you are trying to push it by force F. Okay. Now you place some force. Now you are pushing it, but it doesn't move at all. Okay. So you are increasing now your forces. Nothing happens. So there's a time when you are increasing more force than if you increase it by 1%. If you increase it by 1%, then it tries to slide. Okay, that means if a car broke down, you are pushing the car, or a box lying on the table, you are pushing it. Initially, what you observe, the box or the car is not moving. You are pushing it, you are applying some force, but nothing happens. Why? Because there is also an opposition from its end. So that opposition is known as friction. If now the box is not moving, that type of friction is known as static friction. If you are applying force on any object and object doesn't move, that type of friction is known as static friction. That type of friction is known as static friction. Now, when you increase your force, from a certain some sort of point, when you increase your force beyond a particular point, then your car or your buckle start to move. That maximum force that you are applying, the maximum force that you are applying to overcome the friction, that particular friction is known as the limiting friction. Look, if you are applying force, and the box doesn't move, right? So it doesn't move. So which type of friction is getting? Sir, you will say there is a static friction. There is static friction. And this static friction is adjustable. It is naturally adjustable, naturally. That means if you are increasing your force 1 Newton, it will oppose it by 1 Newton. If you are increasing by 2 Newton, it will oppose by 2 Newton. Up to certain limit. That means if it is limit is 20 Newton. Its limit is 20 Newton. That means if you are applying 20 Newton, it will tend to move. It doesn't move, it will tend to move. That means if you are increasing then 20.1 Newton, it will move then. The maximum force that you are applying to overcome the friction, that particular friction is known as limiting friction. Very easy. Look, static friction is adjustable. You are increasing force, static friction opposes, it increases the opposition. If you are pushing it by 1 Newton, 2, 3, 4, it naturally changes the opposition, but up to a certain limit. That certain limit is known as limiting friction. Beyond limiting friction, your body will move. Done? Clear now? So we are having static friction. In static friction, no movement will be there. Then static friction maximum value. The maximum value of static friction is known as limiting friction. If there is a box, you are applying some force F external, so it will oppose it. Like this. There is opposition of it. So my static friction will be less or equals to my limiting friction. Static friction will be less or equals to limiting friction. Okay. And what is limiting friction? Limiting friction is directly proportional to the normal reaction force. Limiting friction is proportional to normal reaction force. Then it is equals to nu s times n. Nu s means coefficient of static friction. Coefficient of static friction. Done? So what you need to learn that my limiting friction is equals to nu s times n. That's all. Up to now, only this thing you have to remember. Clear now? Okay, look now. Look beta. If you are applying no force, if external force that you are applying is 0, that means there will be no friction. No force, no friction. If you are applying external force and that external force is less than my limiting friction, okay, if you are applying your external force but that external force is less than the limiting friction, that means no relative motion. No relative motion. Done? Now if you are applying external force and that is equals to limiting friction, that is applying to limiting friction, so it just start moving then. Just start moving. It doesn't move at all, but it just start moving. Then if my external force is more than limiting friction, okay, so relative sliding start. Relative sliding starts. Done? And my friction, that means limiting friction, my limiting friction or my static friction gets replaced by kinetic friction. Is it mean? If you are applying zero force, so zero opposition. If you are applying force, but that force is less than the limiting friction, no relative sliding. If you are applying the force and that force is equals to the limiting force, so body just starts. It doesn't move, it just starts. It is on the verge of starting. Now, if my external force is more than the limiting force, that simply indicates the dominant one is now the external one, so your body starts moving. And now if your body starts moving, so static friction gets replaced by kinetic friction. That means kinetic friction is that friction which gets activated if the body is in motion. If body is not in motion, then static friction. If body is in motion, that means kinetic friction. Okay, so look now. I will be giving you a couple of examples. One body, if the speed is 0, that means my net external force is 0. If my force is 0, so friction is 0. Done? Second one, if my limiting friction is 50 Newton, that means if you want to move this box, you need to apply 50 Newton minimum. And you are just pulling it by 10 Newton. Done? So what will be the opposition of it? Sir, the opposition will be only and only 10 Newton. Why? Because it is self-adjustable na? Up to 15 Newton. Now third example. We are having a box. You are pushing it or pulling it by 60 Newton. Okay. Same limiting friction is 50 Newton. Which friction will be there? Static or kinetic. Okay, sir, now my external force is more than that my limiting friction. So that means my external is more than limiting. So the friction is known as kinetic friction. So here I can write, sir, kinetic friction will play its role now. There will be now a kinetic friction. So now you got that point in your mind when there will be a kinetic friction and when there will be a static friction. Okay, now let us start. What basically is kinetic friction? What basically is now kinetic friction? What basically is now kinetic friction? Okay, as I told you that when the two bodies are in motion, so in the motion state, the friction is known as kinetic friction. And my kinetic friction is proportional to the n. My kinetic friction is equals to nu k times n, and nu k means coefficient of kinetic friction. It is coefficient of kinetic friction. Coefficient of kinetic friction. Done? And one more thing. Look now. If my force is more than kinetic friction, so I can write then my acceleration is F external minus Fk divided by m. Second point, if my F external is equals to Fk, so acceleration will be 0. That means velocity will be constant. If my during motion, if F external is 0, then A equals to 0 minus Fk divided by m. It came out to be minus Fk times n. So which simply indicates that it is speeding down. You need to take these things right in your mind. Okay, why there is acceleration? Because acceleration means net force divided by m. If you are having a box, you are applying force F here, so there will be Fk here, right? So F minus Fk equals to mass into acceleration. So A came out to be F minus Fk divided by m. Done? Easy or super easy? Easy or super easy? Look now. Suppose we are having a block. A block of mass 1 kg is placed on a rough surface. Nu is equals to 0.2. Nu k equals to 0.15. First part, what will be the friction force acting on the block? Second part, find acceleration. Look now, beta. Case first, if the force external is 1 Newton, what will happen then? So you can see what you can see right now. My limiting friction is equals to nu s times n. Okay. Now, if it is 1 kg box, that means it is having normal reaction force 10 Newton. So nu s is 0.2 into 10. That means 2 Newton. It simply indicates you need minimum 2 Newton force to just move a body. Now you are applying only 1 Newton. If the required force is 2 Newton, you are applying 1 Newton, there will be no relative sliding. Okay, that means my static friction will be equals to 1 Newton. Now second one, case second, if my external force is 2 Newton now, what will happen now? So my external force is equal to limiting friction. So my limiting friction will be 2 Newton. Why? Because it adjusted its nature up to the limiting friction. Now case 3. Case number 3. If my force is 2.5 Newton, now your force is more than the limiting friction, there will be a motion. I can write here now my Fk equals to nu k times n. Nu k is 0.15 into 10, it is 1.5. Done. So acceleration is equals to F net, that is 2.5 minus 1.5 divided by 10. Done now? 10 or 1? Just 1. Why? Because mass is 1 kilogram. So I can write here, it is 1 by 1, that is 1 meter per second square. 1 meter per second square. Okay, this is how you need to do these things. It is very easy now. Look now, there is one more question now, and that is a famous one. That is pushing a block is easier or pulling a block? If you are pushing something, is that one easier, or pulling something, is that one easier? Which one is easier? Okay, so let us find out which one is easier, pulling or pushing. Let's find out which one is easier, pulling or pushing. Look now, let us take an example now to get this thing done. Look, this is my base. It's my base. On this base, we are having an object. We are having an object. Okay. Now, what we are supposed to do now? We are applying force. We are applying force on it. No. We are applying force on it, and we are applying force at a certain angle. We are applying force at a certain angle. That means if the mass is m, angle is theta, applied force is F. To move this body, okay, what is the force that we need? Okay, if you need the force, first of all, you need to rearrange each and everything. You need to rearrange. How you will arrange it? Look now. Look how you will rearrange it. I have to take like this, no? I need to take it like this. Angle is from tail, no? It is not from the head, it is from tail. It's my theta. F, it is theta. So this could be F cos theta. And this one will be F sin theta. F sin theta. Clear? Look now. My normal reaction force will be downwards. And it is, no, it is not downward, it is upwards. So near, 1 second, look. Down we are having mg, upward we are having normal reaction force. If you just need to move, just move. If your aim is to just move it, that indicates my F cos theta, it should be more or equal to my limiting friction. If you need to just move it, so your limiting frictional force should be less than F cos theta. Okay. Now, look, I can write here F cos theta, there is no issue. F cos theta equals to, what is FL? Is FL my nu S times N? Yes, sir, it is nu S times L. I can write F cos theta equals to nu S. What is N now? N is mg, that is downwards, and plus F sin theta. I can write F sin theta. Okay, done. I can write here F cos theta equals to nu S times mg plus nu S F sin theta. Nu S F sin theta. I can write here F cos theta minus nu S F sin theta equals to nu S times mg. Now I can take F common, so I can have F common. So we are having cos theta minus nu S sin theta equals to nu S times mg. Now my F came out to be nu S mg whole divided by cos theta minus nu S sin theta. So this expression you need to get, right? Okay, is this one good now? Okay, now look, second case. If we are just pulling it now, if we are pulling it, then what will be the expression for it? No, if we are pulling it, if we are pulling it, look now, look, you are pulling it here, right? You are pulling it. Okay, just understand now how you need to find each and everything. Look here, you are applying the force F, mass is m, angle is theta, so F cos theta, then this one is F sin theta, this one is mg, and this could be my n. Okay, same, if you want to just move it now, so F cos theta should be more or equals to FL, or F cos theta should be equals to FL. Okay, F cos theta, what is FL? Is it nu s times n? What is n? N is my mg. You can write it, no? Yes. Why? Because mg is downwards, F sin theta is upwards. So mg minus F sin theta. Now you can write F cos theta equals to nu s times mg minus nu s times F sin theta. I can write here F cos theta plus nu s times F sin theta equals to nu s times mg. Now, so I can take F common, so I can write here nu s times mg whole divided by, it is cos theta plus nu s sin theta. This expression, okay? That means if you are pulling it, you need to apply this much of force. And if you are pushing it, you need this much of force. Now you need to relate pushing and pulling. Okay, you need to now relate. So what is pushing now? Pushing force is F equals to nu s times mg whole divided by cos theta minus nu s sin theta. Okay, now pulling is F equals to nu s times mg whole divided by cos theta plus nu s sin theta. Pushing and pulling. Now you can easily tell which one is bigger. How? Look, numerator of both the forces are same. Cos theta, nu s sin theta, both are same. But here is different. There is a minus and here is plus. You can see the denominator of this one is big and denominator of this one is the small as compared to the both of them. If a denominator is small, the force will be more. Denominator is more, force will be less. That means the more force will be pushing, pulling. So easier is pulling. So I can write pulling is easier. Pulling is easier. So from this derivation, we conclude that my pulling is easier. Pulling is easier. Done, beta? Clear? Pulling is easier than pushing. How? Because we just discussed the whole scenario now. Why this one is easy. Okay, how we can prove it is easy. Done? Now look, as we done stopping distance and stopping time back in our projectile motion or your kinematics, in the same way here we are having stopping distances. Okay, look now, if this is my body's mass is m, and the velocity is u and the speed is u. Okay, so you can write there my kinetic friction will be opposite to it, and that will be nu k times n, and you can write it equals to nu k times m into g. You can write it, no? Okay, now what will be there? Sir, what is acceleration? Acceleration means net force, that is minus fk, no? it will be minus fk by m. Minus fk will be minus nu kn minus m, or it is minus nu k, it is mg by m. M and m cancel out, it is minus nu k times g. Minus nu k times g. So there will be a retardation. If there is retardation, then what will be a stopping distance? What will be a stopping distance? Okay, in stopping distance, as you know, v is 0. So I can write v square equals to u square plus 2 times as. V is 0. So I can write 0 equals to u square minus 2 nu kg into s. So s came out to be nu square divided by 2 nu kg. This is my stopping distance. If I will write stopping time, so v equals to u plus at. V is 0. So 0 equals to u minus nu kgt. So t came out to be u divided by nu kg. Stopping time. This is how stopping distance is u square by 2 nu kg, and stopping time is this much, u divided by nu k times g. Done? Done? Any issue with this particular numericals or particular derivation? Is there any doubt with the particular derivation? Okay. If not, then let us start a numerical. If not, then let us start a numerical. Okay. In numerical, we will be dealing how to find it. Look now, in this particular lecture, you need to be very good in your how to find tension, how to find forces, how to find all these parameters. Then only you will be good in finding frictional forces. Look now, we are having a body. And body's velocity is 20 meters per second. And its final velocity is 0. And it travels distance of 50 meter during from 20 to 0, right? So what will be the coefficient of kinetic friction? Okay, sir, how to find friction of coefficient of kinetic friction? We don't know it, right? So I can write one thing now. Look now, I can write v equals to u plus at, one equation. Second one, v square equals to u square plus 2 times as. Back then. Okay, so if we can derive it, so we can take this one also, right? So it came out to be I can derive it now, there is no issue. Look, v is 0, so I can write it is u square divided by 2 nu is nu k times g, it equals to s, right? U square, yeah. So that means I can write u square divided by 2 sg equals to nu k. U is how much? It is 20. So 20 multiplied by 20 divided by 2 into 10 into 50. 10 cancel out, 2 to cancel out. My answer is 20 by 50. 0, 0, 2 by 5. It is 2 by 5, right? 1, 2 to the 4, 2, 5, the 10. 1 divided by 2.5. Okay. Or you can write it 10 by 25, 0.4. My answer is 0.4. Done? If somebody will tell you after how many seconds or minutes your body will come to a rest. So v equals to u plus at. V is 0. 0 equals to u, then minus nu k times g into t. So t equals to u divided by nu kg. Nu is 20, nu k is 0.4 into 10. Cancel out, t came out to be 5 seconds. In 5 seconds, your body will come to at rest. Your body will come to at rest. Easy numerical, basic numerical. Okay, you need to do these things, right? Now, let us do a numerical in which there is a concept of tension also. Okay, look now. If we are having something like that, something, look now. One box is hanging, mass is 10 kilogram. One box is there with mass m. Okay, you have to find the mass of this box so that everything remains at rest. Everything remains at rest. 10 Newton force will be downwards. There is a tension T. Tension T. There will be a frictional force Fk downwards. There is a m into g and normal reaction force. Okay. If my limiting friction, if my one second, beta. If my limiting friction is more or equal to 100 Newton, this body will remain at rest. What is F is nu equal to 100 Newton. Nu s, let's suppose if nu s is 0, let us suppose 0.4. I can write here 0.5 into 10 equal to cancel out, so my m this way everything will become at rest. That is only possible if the mass of the upper one is minimum 25 kilogram. The mass could be more than 25, no, but the minimum barrier is 25 kilogram only. Okay. One more thing. Look, same numerical. 6 kilogram. There are two boxes. This one is 4 kilogram. This one is m. Okay. So you can see 60 Newton. T tension T. Okay. Fk. What should be the value of this mass? So it should go with constant velocity. What should be the value of this mass so that your system will go with a constant velocity downwards? Okay, look now. That means net force should be 0. Net force should be equals, right? So if limiting friction is equal to tension, and tension is 60 Newton. Limiting friction is nu times S, that means 4 plus m equals to 60. If nu S is given as, let us suppose 0.4, no issue. I can write it is 4 plus m equals to 60 divided by 0.4. It is 10. It is 4 ones are 4. 4 ones are 4. Then here we are having 20. 4 for the 20. Okay. So m came out to be 150 minus 4. So m came out to be, the mass is very high, no? I think we are doing something wrong. It is good, no? 10 m, right? It is good. It is 146. Am I doing something wrong? Great. One second. One second. Is there any wrong? No. The weight shouldn't be this much, no? Okay. There is one parameter, na? I forget it. It is new G, right? G cancel out. So it is 15 minus 4. It's 11 kg. 11 kg. I mess it up, okay? This is how you will manipulate with your numericals and you will get your answer, okay? Done? Clear? Okay, now? Okay. Look now. We are having a bus. This is my bus. A person is in the bus, right? And there is a block of mass m. Bus is going with acceleration alpha. What should be the value of this alpha so that the box remains at rest? Okay. Find out how many forces are acting on it. Okay, look now. Mg is acting on it. Normal reaction force is acting on it. If according to this person there will be an accelerated frame, so I can add m into alpha. If it is getting downward, there will be a frictional force upwards Fk or Fs, no issue, Fs, right? So my limiting friction should be more or equals to m into g. It is nu s times m equals to m into g. Nu s and my n will be m into alpha equals to m into g. So alpha came out to g divided by nu s. G divided by nu s. This should be the acceleration of your bus so that this particular object remains at rest. Done? Clear now? These are very some easy numericals that you can do, right? These are not very tough. Okay? Okay, now there is a angle of friction. Angle of friction is lambda. What angle of friction is? Applied force, normal reaction, my frictional force, contact force. The angle between normal force and the contact force is known as lambda. That lambda is angle of friction. Look now, tan lambda P by B. I can take this thing here now. There is no issue. It is FL. So it could be FL divided by basis N. FL is nu S times N by N. N and cancel out. So my tan lambda came out to be nu times N. It is angle of friction. So angle of friction is the angle between normal reaction force and the contact force. Repose. Angle of repose. Angle of repose. If we are having an inclined surface with angle some, let us suppose angle some theta, we are placing a box on it with mass m. So now we are increasing the inclination. There will be a point where this body tends to move down. That particular angle at which this body tends to move down, that is angle of repose. So you can see here, if it can move down, that means mg sine theta will be downwards. This one will be mg cos theta. Upper will be normal reaction force, and there will be nu s times n, or nu sn is mg cos theta. Okay, in a limiting condition, if we are talking about limiting conditions, my mg sine theta is equals to nu s times mg cos theta. Nu mg cancel out, so sine theta by cos theta equals to nu s. That means tan theta is equals to nu times s. So you can see that angle of friction is equals to angle of repose. Okay, why? Because tan theta is nu s and tan lambda is also nu s. If we are studying angle of repose, if we are studying angle of friction, but what is the consequence? What is the significance of it? No? If you are writing it, or if you are learning it, or what, then what is the application part of it, what is the significance of it? So the significance of nu s, I can write here significance of tan theta, angle of repose. If my tan theta more than nu s, if my tan theta less equals to mu s. So if my tan theta is more than nu s, so your body will come down automatically. Body will come down its own. If my tan theta is less than nu s, so you have to apply some extra force. Some extra force is required to get your body down. Get body down. Okay. If we are having some inclination and if body wants to get down, so my tan theta should be more than nu s. But if my tan theta is less than nu s, then you have to push it. You have to apply some force to get the body down. That is the big thing, right? Done? Easy? Easy or super easy? Look now. If this is my theta, here is my body with mass m. Okay, and it is going upwards. So we know that how many forces are being acted on it. Look, one force will be this much. It is mg cos theta. This one will be mg sin theta. Done. And it is going down upwards, so my friction will be downwards. So you can write my acceleration is net force divided by total mass. Net force will be mg sin theta plus nu k times n whole divided by m. It is mg cos theta nu k mg, oh, it is sin theta, na? It is sin theta mg cos theta divided by m. M cancel out, so my acceleration came out to be g sin theta plus nu k g cos theta. This is my acceleration. So in this particular case, you have to find acceleration. Now, if we are having a different case, if now this is my object with mass m, body gets downwards with velocity v or something like that, right? That means my friction force will act upwards, and same, my mg sin theta is same as downwards. So I can write my acceleration came out to be mg sin theta minus nu k mg cos theta. Okay, divided by m. M cancel out, so acceleration is g sin theta g cos theta. Done? Clear? So these are some cases now that you should know, right? These are some cases that you should know where we need to apply some forces, or where we have to do like this, right? And by doing this thing, we are completed now. So our friction chapter is also completed. Friction is completed. Done? Now, from tomorrow onwards, there is one more friction, rolling friction, that will be completed in rotational motion. So tomorrow we will start circular motion, and there will be a separate and numerical sessions for all these lectures. Okay, don't worry about anything. We are keeping a lectures of numerical practice problems separate for these things. Okay, I guess we are done with today's class. So let us hope for the best, and tomorrow we will be having a class in morning time, the electrostatic one. So tomorrow most probably we will end the electrostatics also. Okay, for today, second step. Okay, I will, there is no issue. Look, I will. This one. Look, beta, look. Simple, no? Look, this is my inclined surface with some angle theta. Here is a box, right? Box is getting down with some velocity v. How many forces are acting on it? Now look now. Mg is acting downwards. This is my normal reaction force, angle theta. So this will be mg cos theta, and this will be mg sin theta. If your box is getting downwards, so my frictional force will act upwards, Fk. My acceleration is net force divided by mass. Look, these two forces are balancing each other, so no issue. Now it is going downward, so this will be a dominant one. I can write acceleration is equals to mg sin theta. These are acting opposite, so I can write minus times Fk whole divided by m. Okay, so acceleration came out to be mg sin theta minus Fk. What is Fk? It is nu k times n whole divided by m. So acceleration came out to be mg sin theta minus nu k n. N is this much. I can write n is mg cos theta whole divided by m. Done. M cancel out. So acceleration is equals to g sin theta minus nu k g cos theta. Done. You can see the answer, right? Look, same answer. Easy, no? Done, no? Easy. So look, this is the fun of live classes, no? If I am just explaining anything and you are not paying attention to my classes, there is no issue. Okay, you are enjoying it, so you can get nothing from it. But if you're coming into my classes, you are paying attention and you are getting some issue with my numerical things, right? You can ask it directly, no? Sir, what is the second step? How you are getting these things done, right? So I will explain it a couple of times. So my suggestion to you is watch the live classes instead of the recorded one. Okay, you can tell me your issues, right? There is one more thing now, that is a two block system, but you won't find a single numerical on two block system. Okay, no PYQ, nothing in your books also, right? So I am taking that out. If you want, so I will on demand will be giving you two box numericals also done, right? But you won't find anything now on two block system. So why create something great, right? So you don't need that thing. Okay. So for today, I guess we had discussed more than enough. If you find any doubt, if you want anything from my end, you are most welcome. If you are having something, any suggestions or anything like that, so you are most welcome. And I am going to upload the whole doubts. Okay, A again. So you want me to explain how we got acceleration part, right? 1 second. 1 second, beta. Okay, I guess my screen is visible to you. Okay, look now. So basically, what is acceleration? Basically, what is acceleration? Okay, so according to the second law of motion, force net is equals to mass into acceleration. Therefore, acceleration means net force divided by mass. Okay, now if there is a box with mass 5 kilogram, okay, you are applying force of 4 Newton. What is acceleration? So acceleration means force is 4 Newton divided by 5 kg. It is A equals to 4 by 5 meter per second square. Now, one more box is there. Look, here is 10 Newton and applying force is 8 Newton. Okay, so it is going in this particular way with some velocity or some acceleration, and body weight is 2 kilogram. What is acceleration? Acceleration means force by mass. Force, bigger one it is 10 minus smaller one is 8. 8 divided by mass is 2. It is 2 by 2, that means 1 meter per second square. Okay, now in the same way, if we are having some inclined body, with mass m, okay, so first of all we need to be very good in writing the forces. So one force will be mg downwards. Look, if it is getting downwards, so that means frictional force should be act upwards. Now mg is here, this is theta, so this could be mg cos theta, and this will be mg sin theta. There is a normal reaction force. Instead of, you can write this thing also now. Look, if we are having two forces, one is mg sin theta, one is fk, and it is going in this way with acceleration a, mass m. What is acceleration? Acceleration is force by mass. Force, look, it is going in this way. This is the dominant one. So you can write mg sin theta minus fk equals to m. So a came out to be mg sin theta. Fk is nu k times n divided by m. A equals to mg sin theta. Nu k is nu k, n is equals to mg cos theta. So I can write here mg cos theta divided by m. M cancel out. So A came out to be g sin theta minus nu k g cos theta. Okay, this third time I am explaining it, and I hope you got this time. Okay, I guess now it is time to just wrap up the whole thing. Okay, beta, and that is a very good thing that you are giving me the responses, right? Giving response means you are acting the class. Okay, doubt doesn't mean that you are not a very good student. Doubt simply indicates that you are paying the attention in the class. If you are paying attention, that's why you will get these kinds of issues. Okay, it simply indicates if you are playing, you will get hurt. No, if you are staying at your home now, you will get hurt. Right? If you are playing something, if you are seeing the match, you won't get hurt. But if you play the match, you will get hurt. The same way, if you are enjoying the lecture now by not understanding what is going on, you will get nothing. Now you will get 0% doubts. But if you are into the lecture, then you will get doubts. That is a very good point and a plus point for you. Okay, I hope today we are done with classes. Tomorrow we will start circular motion in 12th, and tomorrow morning we are having electrostatic class, and I hope we will end electrostatic tomorrow. Then we will start their current electricity, and we will be starting PYQ series, NCRT series as well. If you are interested, you can just tell me, so we can just get those things done very early, right? Thank you, beta. Thank you very much for today's class. Bye. Bye, beta. Good night. Bye. Thank you. Bye. Good night.